In class activity 17B, a manufacturer wants to reduce the amount of pollutants it releases into the environment during its production process. What should the manufacturer consider when developing a pollution reduction plan? Well, the manufacturer may want to consider the cost and effectiveness of implementing the plan. They may also want to know how much time is required and what additional infrastructure or training, employee training is needed to correctly implement the plan as well. Objectives for the activity. You will understand the graphs of rational functions may have horizontal asymptotes. You will be able to write an equation for the horizontal asymptote of a rational function. 2. The manufacturer is comparing two plans for reducing the amount of pollutants it releases into the environment. The plans are detailed below. Plan 1 removes 100x over 6 plus x percent of pollutants, where x is the cost in thousands of dollars. Plan 2 removes 160x over 5 plus 2x percent of pollutants, where x is the cost in thousands of dollars as well. Part A, if the manufacturer is willing to invest $10,000, which plan will remove a greater percentage of pollutants? What if the manufacturer spends $20,000? Okay, so what we're doing here to write this down, P sub 1, we're going to use 10. That represents 10 thousandths of dollars because x is the cost in thousands of dollars. And that's going to be 100 and then times 10 for the numerator. And then 6 plus x is 6 plus 10. And P sub 2 of 10 is going to be 160 times 10. And that's over 5 plus 2 times 10. Now what we can do, I entered this into our calculator up here on the y equals screen, both of these, and we can compare these in a table. So let's enter 10 here for x, and we can see that plan 1, or P sub 1, it will remove 62.5%, and P sub 2, 64%. So it looks like at $10,000, plan 2 is going to remove more pollutants than plan 1. Let's try this again for 20 and see if anything changes. Here, plan 1 is 76.9 and plan 2 is only 71.1. So at 20,000, it looks like plan 1 is going to remove more pollutants. Okay. Let's go back to our paper here. Okay, so this is going to be 62.5, and this was going to be 64. If we do this again, plan 1 at 20, plan 2 at 20, plan 1 is 76.9 and plan 2 was 71.1. Okay. Part B, at what level of investment will the two plans remove the same amount of pollutants? Okay, so what we can do here, we can just equate these two plans. P sub 1 of x is equal to P sub 2 of x, and that would be the same as writing 100x over 6 plus x equals 160x over 5 plus 2x. Okay, and it's going to go up here, and we're just going to solve this for x. Eventually, what we're going to end up with at some point would be x, and then that will be times 40x minus 460, and this is equal to 0. Obviously, then we get the x is equal to 0. That's easy to see here. But specifically, we're going to concentrate on the 40x minus 460 equals to 0. And this is going to end up giving us x is equal to 23 halves, which is the same as 11.5. And that would be 11.5 in thousands. So at what level of investment will the two plans remove the same amount of pollutants? It would be $11,500. And furthermore, if we took the 11,500, the 11.5 we would use, and plug it into either P1 or P2, we would end up with about 65.7% of pollutants being removed. Part C, how much does it cost to remove 90% of the pollutants using each plan? So let's see what we can do here. This time, we know what we want to get out of this. We want 90, and I'm just going to use C1 for the P1, piece of 1 for the example here to start. 100x over 6 plus x. If we solve this for x, we would end up getting x is equal to 54. And again, that's in thousands. So this would end up being 54,000. And this, it's important here, this would be using plan 1, that's piece of 1. And in plan 2 can't do this because plan 2 doesn't allow for 90% removal since the limit is 80%. So plan 1 would work and plan 2 wouldn't be able to remove 90%. Let's go to part D. I'm just going to scroll up here. Part D says, how do the plans compare? If the manufacturer is willing to spend a great deal of money, you decide how much. Well, for a lot of money, plan 1 removes almost 100% of the pollutants, while plan B never removes more than 80. We can even see that on the graph that's included here. You can see plan 2 in the black curve here never even reaches 80, so it's not going to go above 80. Or P1, it's going to continue. If you wanted to keep going and going, it would go pretty close to 100. So part 3, it says graph piece of 1 and graph piece of 2 in the same viewing window. Well, we have a picture of that here. Do the graphs seem to level out, meaning approach a finite limit for large values of x? And we just talked about this, but the graphs shown here, P1 seems to level out at a value of 100, and piece of 2 appears to level out at a value of 80. So function P2 approaches 80 for very large values of x. We say that the line y equals 80 is a horizontal asymptote of the graph. Horizontal asymptotes are often indicated graphically using dashed lines. So for part 4, it says write an equation for the horizontal asymptote of each rational function. So if we look at part A, I'm looking at the leading terms, and I got 12x over 3x. If we get rid of those x's, this ends up being 4. So this would be, what's y equals 4. Part B, f sub 2. Let's see, we have 2x again. I'm looking at the leading terms. We have 2x as the leading term of the numerator, x squared, the denominator's leading term. And the x here is going to cancel for one of those, and we'll have 2 over x. So when we get 2 over x, we're going to get the line y is equal to 0 as a horizontal asymptote. Let's go to part C. I'm just going to scroll all the way up here. And it says, we're still finding these horizontal asymptotes. So 5 times 4 is 20. So the leading term really, I'm looking at these two terms here. We're going to multiply those together and get 20. X times x is x squared. And then the leading term from the denominator is the 6x squared. X squareds are going to cancel. We'll have 20 over 6, which ends up being 10 over 3. So we would get y equals 10/3. Part 5 says the graph of the function g of x has a horizontal asymptote and a vertical asymptote. Write an equation for the horizontal asymptote. So the horizontal asymptote, let's say, we'll take the leading term over the leading term. X's cancel, and we're left with 3. So that's y is equal to 3. Part B says write an equation for the vertical asymptote. So I look at the denominator, x minus 2 equals 0, so we get x equals 2, which is the vertical asymptote. Part C says sketch the graph of a function. Make sure to draw the asymptotes using dashed lines. All right, so if we were thinking, I'm going to put the asymptotes in first. So let's do that here. Just use a different color. Maybe, there we go. So let's do x equals 2. We have a vertical asymptote. And then the horizontal asymptote at 3. It looks like it's right between the 2 and the 4, so let's go. So that's y equals 3. Okay, to decide where to draw the curve, I have this drawn and entered into the calculator here, and we can see to the right of the asymptote, we're going to be above the x-axis, the horizontal axis, and to the left of the asymptote, we're going to be below the horizontal axis. So let's go back here, sketch this in roughly like this, and then we're going to go like that. Let's see. I know this is a rough sketch, but it looks like we're going to be. Let me just draw this a little bit better. There we go. So that's the end of this video. Thank you.